Right, so in this video, we're going to be answering questions about this function. So we have f of x equals e to the power of negative x times or dot square root of x. You can also write it like this, y equals e to the power of negative x dot square root of x. Same thing. Now the first question will be, find the domain of the function. So we have two, so in the main function, we have two other, like two separate functions. We have an exponential function, which is e to the power of negative x. Now, the domain of an exponential function will be x. It can be all real numbers. Okay, so we use the bracket notation. It can be from negative infinity to infinity. Any number can go for x. Okay, 0, 1, 2, 3, negative 1, negative 2, negative, it doesn't matter. But then if we have a square root function, for a square root function, the domain for a square root function, okay, will be x is greater than or equal to 0, because we cannot have a negative number as x. Okay, x is greater than or equal. X can be x can be 0 upwards, or we can say at least 0. At least 0. So we use bracket notation. We have something like this: 0, infinity, meaning that 0 is included. Now, since both you're multiplying, they're together in the same, in one function, you have to combine the two domains here. Okay, if you combine these two domains, you still get that x is greater than or equal to 0. Or you can say find an intersection between the two domains. What do the two domains have in common? So the final domain will be x is greater than or equal to 0. Okay. So the domain of this function, so hence domain of the function f of x is equal to e to the power of negative x dot root x will be x is greater than or equal to 0, or we can write it like this: 0, infinity. All right, so that will be the domain of this function. Now find the x-intercept of the function. Oh, and for this, I'll be doing the first 4 questions in this video, then the next 4 questions, because there are more, but I don't want to spend too much time on one, everything on one video. I'll do it maybe the first 4 this video, the next 4 on another video. So find the x-intercept. Now, at the x-intercept of any function, so say at the x-intercept y, or you can say, or f of x is equal to 0, because this is where the line, so let's say we have a graph here. Let's draw a graph. Sorry about my, okay, and then we have, like, let me use a curve this time. So we have a curve. Let me use something like this. I'm not sure what to draw now. Okay, let me just use like a quadratic curve. Okay. Now, the x-intercept is where the line, okay, crosses the x-axis. It's the x-axis, the y-axis. Okay, so we can hit here and here. So we see that at this point, at this x-intercept, y is equal to 0, because this is 1, 2. Let's say this is -1, -2. This is 0, 0. This is the origin, 0, 0. Okay, so at the x-intercept, y, or f of x, is equal to 0. So it means that we just have to equate. So let's equate. Now f of x will be equal to 0. So it means that e to the power of negative x dot square root of x is equal to 0. Now, I mean, you can see we are multiplying the two. Okay. Now, if this is equal to 0, it means either, okay, look at, if a times b is equal to 0, okay, it's either a is equal to 0 or b is equal to 0, or even both. Okay, but at least one of them has to be equal to zero for it to multiply two numbers and get zero. So that's the same thing here. So it's either e to the power of negative x is equal to 0, or the square root of x is equal to 0. Now, e to the power of x, now an exponential function can never be equal to 0. Okay, a non-zero, let's say, unless unless like the base itself is equal to 0, where you have, let's say, 0 to the power of 1 or 2, that's when you can have 0. But generally, generally a non-zero exponential function cannot give you a 0. So this is kind of, so we can cross this out, because this is, I say, not possible, or let's say not mathematically possible, who knows. Okay, so e to the power of negative x, any exponential function cannot just give you a 0. Okay, it will actually have an asymptote. So on its own, this will have an asymptote, horizontal asymptote at 0. So um it's not possible. Now so this is crossed out. Now square root of x is equal to 0. It's possible if x is equal to 0. Okay, if x is equal to 0, then the square root of 0 can be 0. So this gives us x equal to 0. So it means that at the x-intercept, okay, so at the x-intercept, x is equal to 0, where f of x is also equal to 0. So that's it. All right. Let's see. Yeah. Now find the y-intercept. Find the y-intercept. Now, again, if we go back to this graph, at the y-intercept, that's where x now is 0. So this is here where this curve will cross the y-axis. So this is the y-intercept, and at the y-intercept, x is equal to 0. So at y-intercept, x equal to 0, which we actually got here. We already realized that at where x is equal to 0, y is equal to 0. But still, let's just input it. So we have f of x is equal to e to the power of negative x dot square root of x. Okay, so we are looking for f of 0. That will be e to the power of negative 0. You can just write 0. I mean, negative 0, 0. Try 0 dot square root of 0. Okay. Now, what is anything to the power of 0 is 1 times square root of 0 is 0. So we have 1 times 0, that's still equal to 0. So at the y-intercept, okay, where x is equal to 0, f of x is also equal to 0. Now, what is the sign of the function? Now, the sign of a function, it's for different function, it depends. Now, look, going back to this curve, if it's above the x-axis, it's positive, because y here is now positive, f of x is positive. If it's below the x-axis, it's negative, because the value of y, or you can say the value of f of x, is negative, and if it's on the x-axis, that's like 0. So I like to take this as a boundary for the sign. Okay, so you go above, you have a positive sign. Go below, you have a negative sign. So how do we find the sign of this? Okay, so it's always good to check where the function itself is equal to a 0. Then you can check. Okay, you check where the function itself is equal to 0. You check at the boundary, and then x values to the left and to the right of the boundary. You can check those and see if they give you positive or negative values. However, we look at, we can say now, so we have f of x equals e to the power of negative x dot square root of x now. Now, these two generally are positive functions because they never actually give you a, a negative number. Okay, an exponential function. Okay, an exponential function like this is generally a positive function. E is generally a positive function because e itself is a positive number. Square root function is generally a positive function. So since you're multiplying positive and positive together, you'd expect that the sign of this function is positive. Okay, the sign of this function is positive, and it's only 0 when x is equal to 0. Okay, so we can easily say, all right, now f of x is positive where x is greater than 0, and then f of x is equal to 0 where x is equal to 0. How about when x is less than 0? Now remember the domain of this function. X is greater than or equal to 0. So we can't really check where x is less than 0 because based on the domain of this function, okay, based on the domain of this function, we can't have x less than 0. So we just have two situations where f of x is positive. And if we actually draw the graph, if you decide to draw the graph, we have something like this. I'm not entirely sure, but you can see it's usually above the x-axis, below the x-axis now. So this is generally a positive function. Or you could decide to test it. You can decide to test it where, okay, f of x, where x is equal to 0 and where x is greater than 0. So the function itself is e to the power of negative x dot square root of x. So we tested this before in question 3, and then we still got 0. When x is greater than 0, you can pick a number. I'll pick 1. Okay, I'll just pick 1. So that's e to the power of negative 1 dot square root of 1. Now what's e to the power of a negative 1? That will be 1 over e times square root of 1 is 1. Okay, now we have 1 over e, which is still a positive number. So the actual value of 1 over e will be 0.367 0.3678 7. So just a 7 now, but you can see we still have a positive number. So generally f of x is positive when x is greater than 0. You can see as we keep on going towards the right, 0, and f of x is 0 where x is equal to 0. So that's generally answering the first four questions of this exercise. There are still more, okay, but because I don't want the video to be too long, we'll just stop here and I'll answer question 5, 6, and 7 in the next video.